Thank you. So my title of the topic is what measures to reduce the load on purchasing flow to support the Super PayPay Festival, and I am Tokizawa of Yahoo Japan. So just briefly, I'd like to introduce myself. In 2007, I joined Yahoo Japan, and I have been involved in auctions, shoppings, in other words, e-commerce services mainly. And orders, payment areas that I am going to talk about is the area that I have been involved in since 2019. Mostly back-end development on the server side is what I have been doing. API, load balancing are some of the major tasks that I have been involved in. So this is the agenda for today's talk. So Super PayPay Festival and Yahoo Japan Shopping. I would like to reflect on the past as well as the current status. And then after that, there are four categories of the measures that we are taking: business, system, UI and UX, and organization. These four perspectives will be covered, and then I will talk about the future plans. So starting with Yahoo Japan Shopping. Have you used Yahoo Japan Shopping? I hope that you will use our service. Many merchants are taking part. It's a e-commerce site that is like a shopping mall. Z Holdings companies, group companies are in collaboration with us. Zogozo, Lohako, among others are merchants there, and Value Commerce, PayPay, we collaborate with them as well. And more recently, we have deeper collaboration with Line. And so we are making developments in those areas as well. So Yahoo Japan Shopping, it goes back to 1999. And since then, every year we have a major sale at the end of the year as year-end sale. Especially since 2015, we have started what's called the Happy Shopping Day. So November 11th is the day of a major sale, and that continued until 2019. Now, in 2018, PayPay started its service. Given that, from 2020, we have started conducting Super PayPay Festival. And 2021, last year, there were spring and summer PayPay festivals as well. And 2022, this year, we are actually having that now. So a large-scale sale is what we have, and then the highest daily transaction is plotted on this graph. Since 2014, you can see the daily transaction volume. And in 2022, of course, the sale is underway. It is still going on, so we're expecting the record to go higher than what you see here. But you can see a steady growth. Comparing against 2014, against 40 to 50 times more than 2014 level is what we had in 2021. Now, this is the same graph, but there's a line graph added. Maximum order per second is plotted on the same day. And you can see a steady growth here as well. But for the past few years, you can see the growth has been somewhat subdued. And I'd like to really explain why that is. Now, the orders per second. Well, this graph shows a full day. So what's the trend? So from the left, that's time zero. And then immediately after the start, there's a peak because the people who are waiting for the sale to start will place orders. So that's why there's a peak at the very beginning. And then you follow the day in the morning from 9 to noon. Before noon, maybe, there's a small peak. And then during the day, it's a little calmer. And then towards the late afternoon, or gradually from the late afternoon, orders increase. And then there's the fourth peak, a big peak, almost at midnight. And past midnight, the number of orders drop dramatically. So it gets really calm after that. Yahoo Japan Shopping, as in terms of sales, has been growing steadily. However, on the backside, behind the scenes, there have been troubles, failures, and so we have caused some inconveniences on the part of users and merchants. However, I'd like to pick up some of the successful cases of addressing such situations. Now, I would like to explain the 4 aspects of the approaches that we have taken one by one.
The first one is on the business side. When we talk about business, you might wonder how it comes to the load balancing. We have changed the period of the sale to balance the load. This Happy Shopping Day started from the 11th of November. So per day, how we can increase the transaction volume was the perspective for this one. So we used multi-day period. Before it was a single day period. And there were 4 important things. The first one, the sale period itself was changed to be a longer one because of the markdown efforts during the days. And we are taking about an hour in this November for these days. The second one, we have markdown period and we have grand finale period. And we take 2 days for this grand finale. The last one, the grand finale does not end at 24 hours, and we have extended hours by 2 hours. So this is the countermeasures against people who rush into the same time. So even if it becomes the next day, they can still shop. The second one is about system aspects. This has a bigger impact on this change. Here's a system configuration diagram of the purchase flow, which is very complex. So this is a simplified diagram. Just one by one, I'd like to talk about this. The left side is a user. They pick up a product and they confirm order. And here is the UI. Here we have a cart system. The order is fixed using confirm order button. And the order information comes to the order platform. That's where we store the order information. For example, the change of order by the store and also distribution procedures are stored here. And when the order is received, the payment system is operating in the backend as well. And the system is linked to the various payment systems. In Yahoo Japan, other than shopping systems, we have common infrastructure for commerce, and we have a commerce team. For example, wallet, PayPay gateway, and acquiring. We have different systems to provide services. They are all connected. By having this connection, for example, we can do PayPay balance payment and PayPay card payment. These are common things we have for the countermeasures against high load. We have 3 steps. The first step is to scale out and scale up. Servers and databases are strengthened here. The second is asynchronization. We adjust the flow of information. That means load balancing. The third one, we have rate limit to protect the system. I would like to introduce each one of them. The first one is scale out and scale up. So when we have the sale, we have the indication number for taking countermeasures against high load, and we have web and API servers are scaled out. And as for the database, it's very difficult to scale out. So in these recent years, we upgrade the versions. From Oracle 12c, we have migrated to Oracle 19c. starting from the order. Now all the systems are replaced now. The second one is asynchronization. This is about the database. When writing comes at the same time, it's very difficult. You have to adjust the flow. So that is why we are using the asynchronous writing for the database. And by doing so, even though we have a concentration of orders, we can protect the database. We are developing the same system for payment as well. Very soon, we are expected to release it. Another one is between acquiring and payment. We have this asynchronization as well. So beyond acquiring, we have card companies, and we provide the connection for them as well. So we cannot use all the bandwidth by Yahoo Japan, and we do have threshold that we have to protect, and that is why we have this asynchronization for the protection purpose. The third one is rate limit. So we have certain threshold, and up to the threshold, we can control the access. However, beyond the threshold, we use error to be returned. For cards and PayPay Gateway and acquiring, we have implemented this function. Especially for card rate limit, we have to protect the entire part of the purchase flow. So during the sale, we can change the rate. We can change the configuration. So this is what we have done for load balancing. And from here, I'd like to talk about the database. I'd like to take up the order database to talk about this approach. This is the order database. Cash fusion. We have some waiting event. That was a challenge for us. So I'd like to talk about the order database here. It consists of 6 nodes, a structure with two sets of 3 nodes, and we have store ID as a main key, and also we have order-related information stored here. So the volume of record is very big. When we receive orders, it's inserted, and change procedures can be accepted here, and there is an update after that. And as for the reference, we have 2 different types of references. The first one is to use a list of multiple orders, and another one is detailed reference. So you can look at the detail of the information about the orders, and also the access comes from the users as well. And especially at this list to refer by users is the heavy part in terms of the heavy load. And this is before taking countermeasures. We have 6 node structure and configuration, and the access is distributed using a database client. Suppose toward node 1, there is a flow of orders. There is an insert. And after that, at the same time, the same user's reference request for the list comes, and you have to reflect the order received information on node 1 to node 3. And this was the thing we have done to address it.
So using the CQRS pattern, we are separating the referencing and updating. And here again, there are 3 major pieces. Let me explain. The first one is sharding. Store update and reference is addressed here. And then the second one is read-only replica that is made ready. Again, this is for referencing. And number 3 is data source isolation. the user list referencing was the heaviest in terms of the load. So we have taken some measures there. So starting with sharding, evenly distributed access was what we tried to do in our processing. But because the store ID is the primary key, so we can actually change the access destination on a per store or merchant basis. So store A orders will go to node 1, and then store C orders and reference will go to node 3, for example. And so they have common data, but the request destination will be different according to the scheme, and we were able to reduce the load. Now, in the past few months, the access information as well as order information are checked so as to have evenly split access. Next is a read-only replica. On a per store or merchant, sharding was done, but because they have the same data, we have this collaboration of the data card in an asynchronous approach, and so referencing has been switched partially so that the load on the original node will be reduced. One challenge there was data guard will be asynchronous. Therefore, for requests that needs to do a referencing in real time, we were not able to include that in this replica. So we had to select things that do not require real time performance or processing. Third is data source isolation. The user list was really heavy in terms of the data load, and so we try to limit the access there. What I mean by that is order information in the database, just part of that data will be separated out to be stored in the KVS. Cassandra was selected this time, and once we receive the order, before the database, the KVS will have that written in, and then there will be an update. So that's how things will take place. And we have a dedicated API, and for the different front end destination, we steer that to the KVS so that the load on the original node was reduced quite dramatically, and we believe that that was a successful countermeasure. Next, I'd like to talk about UI, UX, the third piece. I mentioned the KVS, but actually here, there is something that led to the solution. After the KVS writing, database writing was asynchronous, and therefore, to what extent asynchronous processing was not something the users were informed on. And so we were able to resolve that by the use of KVS, and the UI was prepared by the design team. The left-hand side is the order completion page or screen saying that order is completed, but instead it says it is in process. In other words, it has been accepted. However, it is in process. It's not finished, but it is pending. It is being worked on. And on the right-hand side, you have the order history list. Again, this in process, a message will show up. We made it happen. And so the user can rest assured that the order has been received and accepted. Another aspect of the countermeasure is congestion forecast that we are displaying, because there are certain tendencies of the axis, the congested versus not so congested hours of the day. Of course, we want the users to use our service during those non-congested periods. And on some pages or screens, we have such congestion forecast shown. And we were able to steer users to access the site at a different time period during the day. And when rate limit is used, errors were returned. However, the users would interpret that as an unfortunate experience. he or she wanted to buy something but was rejected. And so we have this apology screen to notify the user apologetically. And again, we have this congestion forecast, and we guide the users to the time of the day where there is not much congestion. And also, information can be updated just like the previous graph. Let's move on to the fourth piece, which is organization aspect. Before the sale happens, we have to prepare. And in case of Yahoo Japan Shopping, we have this load test for the entire system. We apply load to all the systems to make sure that there's no problem all the way to the final piece, the destination. And the purchasing flow is taking part in that. It's not just shopping department, but all the relevant departments are involved. PayPay Card, among other entities, are involved as well in conducting this load test. And for the entire Yahoo Japan, this is something that we are addressing. So we are organized underneath with the leadership of the CTO. We have the relevant headquarters involved, technical directors, the technical heads are taking part so that we have a cross-functional team to make sure that we're ready. So the overall policy and also collaboration and the linkage amongst the different parties are looked at for a smooth collaboration across the entire organization.
We are using the same idea for shopping as well. We have created an SRE organization. They're in charge of features and functionalities. Usually they are reducing toils for efficiency as well. And they have load balancing for the sale as well. This load balancing per component is changed so that they can do cross-component approaches. So now the countermeasures are taken very smoothly. Accordingly, business, system, UI, UX, and organization, we have done 4 initiatives, and this is the result. So here is the result in 2021. The Super PayPay Festival Spring. The left side, this was unassumed. There is a huge peak at the time, and we didn't expect this, but we were able to process it. And as for the trend is the same. However, the last minute shopping around 24 hours, we had a different campaign afterwards so that we were able to reduce the peak. And this is the Happy Shopping Day 2019. This is a comparison with that day. You can see it very clearly. The last minute rush apart, we were able to reduce the peak, even though the starting part was unprecedented and we were not imagining it. And at the time of the start, they rushed into the starting time. So our engineers really wanted to purchase some things. However, there is this out of stock situation. I really hope the stores can have more stock so that we can purchase more. This is about the future. We would like to brush up the UI and the UX for the users. For example, display during the receiving orders and also congestion, and that was displayed to give information to the users. But at the time of the sale start, we'll have to address more. And this is another challenge for me. And when trouble happens and how to communicate with the users is something we can improve. So we'd like to improve this one too. And the third one, this is a different approach. What I was describing was that after purchasing asynchronously, they have to wait. But probably before, placing an order, they can wait. For example, on a real-time basis, you can imagine there is a line, there's a queue before the cashier, and this is something we are doing for the EC site. So in our company, we can address the same thing. The next one is improvements for the stores. For stores, we are providing some tools, and we are using notice frame to communicate. For example, we are using this notice frame to notify trouble as well. So this is something we can improve as well. And about asynchronization, the display of receiving orders cannot be seen by the stores. So this is something we can improve as well. Single points of failure. Still, we have some of them, so this is something we have to address. We'll have to review the organizational structure. Even though we think we're ready, sometimes trouble and failures occur. So we would like to review our organizational structure to address any situation. We have an SRE team as well, for example, how to notify, and also the division of roles and duties and user communications. We would like to improve our measures. Thank you very much. With this, I would like to complete my presentation.
伊沢さん、
Thank you very much, Mr. Tokizawa. From here, we have Plus Talk, where the interviewer will actually go deeper into the content of the session. And we would like to accept questions from the audience as well. If you have any question, please click on the question mark at the bottom right on your screen and send your question. And the interviewer is Ms. Ikuko Hiraga of LINE. Ms. Hiraga, can you introduce yourself? LINE Live server-side development is what I'm doing at LINE. My name is Hiraga. It's a pleasure to see you all. Thank you. Okay, Ms. Hiraga. So here in the session, what impressed you most? Well, I'd like to just make some comments. Load balancing, when you hear that, you think it's about servers. But when I listen to your session, business side is included. You're actually thinking about the whole picture to think about load balancing, and I found that very interesting. So thank you very much. So I'd like to ask my question, but the system configuration that you showed us at the beginning, I have a question. So this is more about the assumption rather than the content of the session. So I'm not so familiar with the internal Yahoo Japan system. So you have this gateway acquiring, PayPay gateway, wallet. Can you explain the difference between the three? The impression is they're all related to payment, but settlement, it should come from settlement, all three? Okay, I understand. You're correct, though. Well, it's been simplified, so it looks like this, but wallet, credit card information is registered by the user, and then that makes it easier for them to shop. And then PayPay Gateway, as the name says, this is connection or collaboration with PayPay, and acquiring is connected with the credit card companies, and so acquiring actually summarizes or puts together all these different card companies. Wallet, PayPay Gateway, they're also connected to the settlement as well. But which part is the user purchasing is what I wanted to capture here. And PayPay Gateway, from order to actually you are subtracting the balance. However, after the event, a payment can be also an option these days. So they want to get closer to settlement. That's what the internal people want to show. So it really depends on what you want to realize. Okay, I understand that. Now, I'd like to ask a question about the content.
KVS, using KVS, you're using KVS. This was very impressive. This one? Yes. It was very impressive. So KVS, for example, there's a failure at KVS. What happens? This KVS, this carries part of the order database. So if there is no problem about the load, you can switch to the order database to address any situation. However, KVS fails. For example, you cannot display the order is being processed and received, and that is the only thing. So that means even if you look at the order TV database, you cannot display it. No, it's not written here. But after writing into KBS, there is this asynchronization processing. So depending on the time required, it takes time. So if it's not congested, you can display it. Okay.
Another about KVS. So you write into the KVS first. So when there's an error, you can actually erase what you wrote in KVS. But after the writing is over, and then the server restart may happen, and then maybe, when there's an error where you cannot erase KVS, I think there's going to be a mismatch between the DB and the KVS. So is there any life set for the KVS, for example, to address that situation? Well, again, the diagram doesn't express that, but at the time of ordering, yes, we write into the KVS first, but after that, basically what's been written, then there will be synchronization in KVS. So status update happens, and then the KVS will actually go through update later. So we can cover for that situation. But yes, at the time of order, it's been written into KVS and it goes down. That might lead to, yes, trouble. But the asynchronous part is what this covers. In other words, recovery will happen before writing into the database. Okay, so temporarily there might be some errors or some mismatch, but then afterwards there's some asynchronous process that will correct the situation. Yes, and if I may add, the in process message is where the order has not been completed. So 1 week after the KVS, it will automatically be erased. So at the worst scenario, you wait 1 week and it's gone. Okay, I understand. Thank you.
じゃあ、
So about this one, there's another question. I'm sorry, this is too much in detail, but KVS, you have a new application server when you use this KVS. Is that because of the load on the database? If that's the problem, API itself, you said it was switched to a new URL. The application server, you could have used an old one. So the reference of the list, we have a feature functionality that includes searches, and this is out of the scope of KVI. For example, KVS can display the history of orders. However, when they want to search, they have to access to database. And we have less data source, so the contents of the response is different. So that is why we have a new application server. And another thing is that the order history in KVS can be displayed at a front because this is the data we can use for recommendation, and we would like to scale this going forward. So KVS and this application server can be separated so that we can do recommendation as well. So understand. Thank you.
And a totally different subject. There's a question from the audience. Let me read that. Rate limit. Is there any kind of a firewall that you're using for rate limit? Rate limit. Yes. Here. Inside the company, we're providing information. There's a platform that we use, and we customize that platform, and we're using that now. In terms of a mechanism, I think it's the same. For the cart part, though, local on a local level, I think we manage it to control the number of requests. Okay, thank you.
と違う話を聞きましょうか。はい、なんかちょっと
This is a general question. At peak, when you are receiving order, the maximum peak hour, the maximum peak type, because this is asynchronization. So before taking these countermeasures, or immediately you could complete the transaction. But what's the time at the peak? It depends on how much we have during the asynchronization. It's hard to answer, but for recent sales, we have some other countermeasures that are very effective. So maximum maybe some minutes we can complete the processing. That is because, very often I have less balance on my PayPay, and I want to know when I have to add more to my account because it's asynchronization. Well, maybe during the time in 3 days, maybe I cannot really pay. So starting from order to PayPay Gateway, there is another line here. I can use this asynchronization picture. Before the order is written in the database, that's where we are using this asynchronization. So before the completion of order, the last part, that's only when writing into the database, that is where we are using asynchronization. For example, communicating with the credit card, and we do have the access already, and the balance is already subtracted. So from the balance, the money is already subtracted. It's not written in the database, right? And there is another asynchronization toward acquiring as well, because for asynchronized authorization, there are some cases where we generate errors because authorization is done. So this is something we are addressing right now. Yes. So with asynchronization, you have complexity. Yes.
そうなんですね。
I see. Okay, so an overall question. System-wise, you're taking multiple measures for load balancing purposes, but what was the most challenging for you, or what was the one measure that impressed you most? Well, I touched on this already, but what became more problematic or difficult was the asynchronization, because everything used to be sequential. Everything was completed and it was okay, but then things actually happened afterwards. This is more of a test case, and so I think the engineers are having some difficulty, so we have to come up with some countermeasures. And I'd like to touch on another thing. KVS. Here, scaling is possible. I think I mentioned that. And the order history will be leveraged a lot. So I think we have high expectations for the usage of that in a positive way. It was a lot of a challenge. However, we have things to look forward to as well. Yes, I fully understand your thoughts there. Thank you. Thank you very much.